Let's draw the Lewis structure for CO2, also known as carbon dioxide. So the first thing we need to do is count the total valence electrons from all the atoms. And if we look at a periodic table, we find that carbon is under group 4, which tells us that there are 4 valence electrons in carbon. And oxygen is under group 6, and that shows us that there are 6 valence electrons in oxygen, and we have 2 oxygens. So we need to multiply this by 2. And that gives us a total of 16 valence electrons. We'll start by drawing these atoms out side by side. And the reason why we put carbon in the middle is because it is the least electronegative. You could access the electronegativity chart by clicking the button above this video. So let's continue by adding these single bonds that connect these atoms. Now remember that each single bond represents 2 electrons. So right now we have drawn out 4 electrons, and we have to draw out 12 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've drawn out all 16 valence electrons, and now we have to look at each atom to see if it has a complete octet. Let's start from the oxygen on the right. 2, 4, 6, 8. There's a complete octet there. The oxygen on the left, 2, 4, 6, 8. There's also a complete octet on this left. And in the middle, for carbon, there's only 2, 4. So there's not a complete octet for carbon. And what we need to do now is to actually move non-bonding electron pairs from the outer atoms into the bonding position between the atoms. Let's just clean this up. And now, again, let's check if each atom has a complete octet. 2, 4, 6, 8. 2, 4, 6, 8. And carbon, 2, 4, 6, 8. All right, each of our atoms have a complete octet, and we're done with this structure.